All right, all you brilliant advanced algebra kids, we're going to take a look at the second part of chapter 6.6. I think this is going to be probably a pretty short video here because we've covered most everything, but let me just do a quick review. Standard form is y equals ax squared plus bx plus c, standard form of a quadratic. And vertex form is that form y equals a x minus h squared plus k. Now let's just compare again what's what, okay? If you want to go from vertex form to standard form, you would just expand this and you'd end up with standard form, okay? To go from standard form to vertex form, this a is the same as over here. And what is h and k? Well, h, k is an ordered pair of the vertex. So you would have to find, the vertex. You would have to find the vertex over here using x equals negative b over 2a. And once you know the vertex, then that'll give you the h value there, and then you can plug it back in to find the y value. Now hang on to this form here because we're going to be mostly working with vertex form today, but you may be asked to put it back in standard form. Now this is all talked about quite a bit on part 1. So let's move on and talk about what's in this next section here. All right. Well, the main thing we need to talk about here today is how to write an equation given just a teeny bit of data. And we have some data here. We have two ordered pairs. By the way, we did this on exponentials where you were given two dots and you have to come up with an equation. And if you recall, we did this way back in linear equations too, where you were given 2 points and you had to find the slope, and then you could write an equation with a point and slope. We did this in exponentials where you had to go use the two dots to help you find the rate or the base of an exponential. Well, we're going to do the same thing here, and we're going to use this formula. It's an equation of a quadratic. It said in the problem it actually said it was a parabola. It didn't say that here, but I should probably put that of the parabola. Well, if it's a parabola, we know it's a quadratic. So this is y equals a x minus h squared plus k. Now we're going to use the vertex form, and the reason is that because we know the vertex. It's right here. And this is actually a pretty easy problem to do. Now I want you to look at all the letters here. Y, a, x, h, and k. 5 things. 1, 2, 3, 4, 5. Well, there's 5 letters, and there's actually 4 numbers here. So one of the letters is not going to get plugged in for, but we're going to plug these 4 numbers in for 4 of these letters. Well, which is which? Well, the vertex, we've said, is h and k. So the vertex is negative 1, 4. We're going to plug that in right here. Oh, negative 1. And k is 4, okay? So there is, I plugged the vertex in. So insert the vertex, and we've done that now. We plugged k in here, and we've plugged in h. By the way, I can go plus plus here, can't I? And now I also have another ordered pair here. This ordered pair is one of the points. I only need 1 point, one of the other points on the graph. And notice this is an xy pair. So we're going to take x and y and go down here and plug in x and y. So y is 1, a we don't know, x is 2, and there you go. Now what this says is we know 2 points on this graph. We know there's a vertex at negative 1, 4. And we know there's another point at 2, 1 right here. Well, if that's the vertex, and it's got to go through this point, it's going to have to open down. See that? if this is the vertex up here, it's going to have to open down. This point is telling us whether we're going to open up or down. This point is telling us whether a thing's going to be flattened out or squished up, or what's happening to the graph. We know where the vertex is, so it's not going to translate anymore. But it just this extra point here is what we need. We need this point to find A. A is that number up front that tells us a couple things. It tells us, does it open up or down? In other words, is it negative? And it tells it, is it stretched or is it flattened out? Is it squished this way, or has it been stretched? Okay? So this whole process is being done to find A. And A is going to be that defining number that's going to tell us what's happening to this, the shape of this graph. Are we stretching it? Okay? So we're going to go ahead and solve this. This is 3 squared. I'm going to do the order of operations properly here. This is 9. 9a plus 4. Let's subtract 4 from both sides. We get negative 3 equals 9a. And divide both sides by 9. And we discover that a is a negative 1/3. A is a negative 1/3. Now, that makes sense that it's negative because it's opening down. And negative 1/3 means it's kind of flattened out a little bit, because this number 1/3 is a little bit less than, it's less than 1. So I expect this to be flattened out and opening down. So now I know my equation. I'm going to need some room here, so I'm going to, I don't know, stick it in over here, I guess. The equation is going to be to use all the information I have plus A. So y equals negative 1/3 x plus 1 squared plus 4. Ran off the side there a little bit. Now that's the equation. Now let's verify that that is in fact the equation. We're going to put this in our calculator and see if it doesn't pass through these 2 points. So let's go get the calculator and do it. Okay, so I've gone ahead and plugged in that equation into my calculator in the y equals screen. You'll notice that I put the negative 1/3 in parentheses. That way I don't end up accidentally multiplying 3 times this. I want to make sure that it's done right here. So I use parentheses for the fraction. And by the way, don't use the decimal negative 0.333, because that's a rounded number. You want to use no rounded numbers in your problem. So now let's see what happens. I'm going to go ahead and make this a little bit bigger so we can see the whole screen better. Let's see what this graph looks like. Let's go ahead and graph it. I'm going to graph it in a standard window, so I'm going to zoom, standard, and that's the picture that we saw before. Okay, and you can see by looking at this that our vertex, let's go look over here, our vertex is right here, and it's at negative 1, 4. That's what we expected. We also expected to find a point at 2, 1. Let's go over here and see at 2, 1 would be right here. So that is the right graph, and it is the right equation. If I wanted to make absolutely certain, I can look at table. So let's go to table here. I'm going to have to change my table setting, so I'm going second window, table set. Let's start at 0 and go by 1s, shall we? Start at 0 and change by 1s. And let's take a look at the table. Okay. Now there's the table. Let's back up a little bit here. We can see that the vertex is right here at negative 1, 4. And you can see that negative 1, 4 kind of is that midpoint between these two, so it's obviously going downhill in both directions. So negative 1, 4 is in fact the vertex. If we look down a little farther, we see that this point 2, 1 is on the graph as well. So we got the right graph here. And that's just verifying that that equation in here is the right equation. And you can see again that the vertex, just looking at the equation, equation here. X minus a negative 1, 4 is my vertex. And the a value is negative 1/3. So negative means it opened down. 1/3 means that that graph got squished. So as you look at this, the graph is not real flat here. It's not real flat here, but it is a little flatter. Just to verify that, let's put another one in where that number up in front is just a 1. Okay, so you can see that it's actually been squished down a little bit here. X plus 1 quantity squared plus 4. I just put the same equation in, but I'm changed the a value so you can see that our graph has really been flattened out a little bit. Oops, I forgot a negative there, didn't I? So let's go back here and put the negative, and that should be a negative here. And do it again, okay? There's our graph, and this is showing that right there, same vertex, but the graph, the blue one here, has been flattened out a little bit, and that's because of that a value, which is less than 1. Common fraction is going to cause the graph to flatten this way. It's going to squeeze it. A number bigger than 1 is going to cause it to stretch it both ways, stretch it vertically. All right, that's basically the assignment for today. Let's do a couple more of these, okay? All right, this is the problem from page 326. It gives us a vertex and a point, and the instructions are the same. Write an equation given this data. You know, this is wonderful because if you know you have a quadratic function and you only have the vertex and another point, you can actually write an equation for it. So we're going to do that. This is h and k because it's the vertex, and this will be x and y because it's some other point. So here's our form. We don't know if it opens up or down yet, and we don't know whether it's been stretched vertically or whether it's been squashed down vertically. Okay, so let's plug the values in here. Well, y is 4, a is what we got to find, x is 1, h is 2, and well, that's not supposed to be 4 there, it's supposed to be k, and k is 0. Okay, let's check it again. Y is 4, x is 1, h is 2, k is 0. So you're just going to plug all those in, and a is the only one you don't know. So let's go ahead and do the algebra here for this. This is negative 1 squared. I don't need to write the plus 0 there. 4 is equal to a. Negative 1 squared is a positive 1, so a is equal to 4. So my equation for this is I'm going to plug it in to the equation, but leave the point out. I'm going to make sure that y and x remain. So a is 4, x is remaining, h in this case was 2, and k was 0. I don't need to show the 0, but I'm doing it just for emphasis. So there's our graph, and if we were to look at this now, we see that our vertex is at 2, 0, and we got a point at 1, 4 right here. We can see that if this is the vertex down here, it's going to have to open up. And that makes sense because our a value is positive. It's a positive value, meaning that it's going to open up. So we could put that in the calculator and check to see that it's the right picture. Okay. We should see that it's going to squash down. So let's put it in the calculator here. Okay. All right, I've gone ahead and plugged that in the calculator here. Let's go ahead and take a look at it. I'm hitting zoom standard, and the vertex is at 2, 0. And as you can see, the graph has been stretched a little skinnier. It's not skinnier, it's actually just longer. Okay. Remember that whatever we do after the prevailing operation affects the graph vertically. And so let's take a look here again. As you look at this, once again, you can see that this 4 is being multiplied times this after the prevailing operation, which is the squaring. So the 4 is going to stretch it vertically. Anything done after the prevailing operation affects the graph vertically Okay, and anything done before the prevailing operation, like this 2 here, affects the graph horizontally in a manner we don't expect. So this should shift the graph to the right 2. And you say, well, it's negative. Yeah, but it's in a manner we don't expect. It's opposite from what you're expecting. So it should be shifting the graph to the right. And that's what we have here when we look at the graph. It's been shifted to the right, and the graph has been stretched vertically. Let's just verify that. Let's go ahead and put this same function in here with a 1 instead this time, just to verify that 4 caused it to stretch vertically. Okay. Yeah, the blue one now has been stretched vertically. The red one would be with a 1 as A, and our 4 has caused it to stretch vertically. And any number bigger than 1 will cause it to stretch. Any number, between 0 and 1, a fraction, will cause it to squish down. Let's do one more. All right, let's take a look at problem 14. It's a word problem. I'm going to put the book up here for a minute so we can kind of discuss the picture a little bit. All right, the height of a fountain's water stream, the height of this water stream, can be modeled by a quadratic function. Suppose the water from a jet reaches a maximum height of 8 feet at a distance 1 foot from the jet. Find a quadratic function that models the height. Now, if the water lands 3 feet from the jet, so down here at the bottom, this point lands 3 feet from the jet. Let's decide where we want the x and y axis to be. Let's make the x-axis right at the water level. So this ordered pair down here is something 0. In fact, if we make the vertical axis even with the jet, this point here would have to be 3, 0. We'll draw a picture of that here in a second. And the jet here would have to be 8 feet. It says it reaches a maximum height of 8 feet. So that vertex at the top is 1 foot from the y-axis. So that ordered pair up there would have to be 1, 8. Let's draw that picture with some lines, shall we? All right, let's just start with these two things, the water and the jet. Now it says that the graph, the water shoots up a little bit and then it comes back and lands in the water. We're going to let the water be the x-axis out here. Okay, that's the x-axis. And let's let the jet be on the y-axis. Let's let the jet be on the y-axis. So we can see that this ordered pair, according to your drawing there, this ordered pair here has to be at 3, 0. Okay? And also says that it reaches the maximum height at 1 foot away from the jet, and the maximum height was at 8 feet. Okay, it's 8 feet. So this ordered pair here has to be 1, 8, and it's the vertex. So we know because it's the top, it's the maximum here. So from here to here is 1 foot. Okay, and then from the water it's 8 foot above the water. Let me read it again. It says it reaches a maximum height of 8 feet at a distance 1 foot from the jet. Okay, if the water lands 3 feet from the jet, it's right here. So there are 2 points. So the hard part about this problem is really just making sure you know what those ordered pairs are. We could have let the y-axis be at the vertex, but that probably would have made the problem a little harder, not necessarily. But we're going to go ahead and find the quadratic equation because they want us to come up with a quadratic equation that models this situation. Well, since we know the vertex, we're going to use vertex form here. There it is. And we know that V, the vertex, is HK, and this other point down here, this is X and Y. So we're going to stick both of those in here. All right? So Y is 0, A we don't know, X is 3, H up here is 1, and K is 8. There it is. HK 1, 8, and XY would be 3, 0. X and Y. So all those values are plugged in there now. Okay? Now at this point, you can finish it, but we're going to go ahead and finish it with you here. So this is 2 squared. Let's subtract 8 from both sides here now. And we've got 4a. And now dividing both sides by 4, we see that a is a negative 2. And it makes sense that a is negative. Why? Well, because it's the parabola is opening down, right? So if a is negative, that makes sense because your parabola is opening down. So the equation has to be y equals a value is negative 2. We're going to leave x and y in this equation. And the vertex is at 1, 8. Don't forget that minus sign is part of your formula here. X minus the vertex. So there's your equation for the problem, and that's our goal is to try to come up with an equation, and we did that. So you'll enjoy this section. This is powerful stuff. So I'm going to let you tackle this thing. We're going to take on another section probably before the end of this chapter. Chapter's coming up soon, and your chapter test is going to be here before you know it. So let's give you the homework for tonight. All right. Well, here is the assignment for the second half of this section. This is number 44. We've done a few problems here for you already. I'm going to let you wrestle a little bit with those word problems. The answers are either in the back of your book or on that online answer key. So make sure you spend a lot of time in this section on analyzing graphs, particularly understanding this whole idea of vertex form. Okay, so enjoy this. Your test is coming up next week, not this week, but next week on Thursday. Let's see, that would be May the 28th, and it's going to be at 6:55 p.m. That's your test, okay? If you got a question about something, send me an email. I'll see if I can Zoom with you. And I'll be available for tutoring on Fridays at 2 o'clock. Please be there if you need it. Otherwise, you're kind of on your own for review unless I hear from you. All right? Take care.